good morning. This is Kasturi De. I was continuing in my last video the heat chapter according to ICSE syllabus class 7. Okay. So I was telling you about the relationship between the three scales of the thermometer. I told you that T degree centigrade, that is the temperature which we have to know, is found by adding 273 Kelvin plus the temperature on the Celsius scale. Adding 273 degrees centigrade to the Celsius scale, we get the temperature of the Kelvin scale. Temperature on the Kelvin scale. And in Celsius and Fahrenheit relationship, it is C, excuse me, C by 5 is equal to F minus 32 by 9, whereas C stands for Celsius scale and F stands for Fahrenheit scale. I told you that the change in temperature of a body depends on the quality of the heat imparted to or rejected from the body. How much the heat it has taken or given out. The material of the body, what is the material made up of? The body whose temperature has to be detected. What is it made up of? Which material it is made up of? And the mass of the body, how heavy is the body? So that depends on the temperature of the body. Now, what is the change in the size of the body? That is thermal expansion. Okay. Now, this is also a change which appears due to the heat energy. When a body is heated, it expands, and when it is cooled, it contracts. That is thermal expansion. That is the expansion produced in a matter due to the absorption of the heat energy. Okay, the expansion which is produced in a mass, in a matter, how much the matter has expanded. Okay, so that depends due to the absorption of the heat energy. After absorbing the heat energy, how much it has expanded. So that is thermal expansion. It occurs in solid, liquid and gases in the three states of matter. In solid, the thermal expansion is known as linear expansion. In then superficial expansion and cubical expansion. Okay, three types of expansion are there. Okay, so in solids these are three expansions: linear, superficial and cubical expansion. Linear expansion is increase in length. Superficial expansion is increase in area, and volume, the cubical increase in volume is the cubical expansion. Now, application of the thermal expansions of solids, where we can apply these type of expansions. See, small gaps we see are left between the successive rail tracks. In the railway tracks, we see that when the railway lines are placed, they are put on the tracks, so there is some gap left in between. Why? Because in the summer, when the these heat increases, the railway tracks are made up of metal and they absorb the heat energy from the sun and they expand. So if they are fitted tightly, then they due to the expansion they will bend, and there can be accident, because if the rail tracks bend, the wheels which are going on the railway tracks, they will not go straight and there can be accident occurring. So if they are kept a little more gap, small gaps are kept, so when they expand they will touch each other. Okay, there will be no derailment. Then the iron girders which are used in the bridges, okay, they are also one happens that in the iron girders which are kept to make the bridges, one end is fixed and the other there is a roller fixed in it. Okay, why? Because the end which is resting on the rollers is free and it can expand in summer and contract in winter. What happens? This prevents the bridge from getting damaged. Now, the telephone wires we see, and electric wires we see that they are sagging between the poles. Why? Because if they are fitted tightly in winter, these telephone wires will contract due to the cold. Okay, so when they contract, if they are fitted tightly, they will break in between. They will snap. Okay, so to avoid that snapping, they are kept sagging so that in winter they can contract, and in the summer they will again sag down. Okay, this prevents sagging. Then bimetallic strips are used in thermostats, in electric heating strips like electric iron, geysers, toasters. Okay, this bimetallic is, one is of iron, another is of copper. What happens? This controls the temperature. Okay, one is iron and one is copper. So these two bimetallic strips are given in the thermostat and electric heaters. Okay, and electric irons, geysers, toasters, so that they can control the temperature. Then again, the wooden wheels. We have seen some bullock carts, when we go towards the countryside or in villages. Okay, so there, when the bullock carts are there, the wheels are made up of wood, but the outer rim is made up of iron. Iron rim is attached to the wooden wheel. What happens while fixing the iron rim on the wooden wheel? What happens? They are made a little bit smaller than the wooden wheel. Why? Because when they are fitted on the wooden wheel, they can fit tightly. Before fitting it, what happens? The person who is fitting, they will heat up the iron wheel, okay, iron rim, and they will fit it into the wooden wheel, and then when it cools down, they will fit tightly. Otherwise, it would have become loose. Okay, so to fit it tightly, they are making it a little bit smaller. Then a cement floor is not laid out in one piece. Why this happens? Because if it had been made in one piece, then during summer, due to the expansion and contraction in the winter, they will break. So we see that when the cement pieces are kept, when pieces are laid on the floor, cement pieces, there are small gaps are taken, even sometimes glass strips are placed in between, so that these gaps are filled during summer, and the winter they can contract easily. Okay. Next we come to the thermal expansion in liquids. Okay. Like solids, liquids also usually expand on heating, and liquids expand much more than solids, because we know that solids are compact. The molecules of the solid are fixed in a position. They do not move in very much, but in liquids they are a little bit free to move. So the liquids expand more than the solids and when heated. So they do not have a definite shape but have a definite volume. Therefore, they have only the cubical expansion. Liquids have only cubical expansion. Now, exception is water on heating from 0 degrees centigrade to 4 degrees centigrade. The water contracts, and then on further heating it expands. So, when we are raising, we know that when we raise the temperature, the matter expands. But in case of water, what we see that from 0 to 4, it contracts. And after 4, again, it expands. After 4, if we heat it, 4 degrees centigrade, it expands. So, different liquids expand by different amounts for the same rise in temperature. And mercury expands more uniformly over a wide range of temperature. That's why it is used in thermometric liquid. Then expansion of gases, thermal expansion of gases. Here, gases also expand and when they are heated. And we know that gas molecules are much more free than the solid and the liquid. So they expand more than liquids and even solids also. So they have only cubical expansion. They do not have any shape. Okay. Now change in state. Matter exists in three different states. So matter, we know that they exist in three different states, solid, liquid and gases, and the process of change from one state to another, that is from solid to liquid or liquid to gas or solid to gas. So these are the change of state which appears at a constant temperature. Now the change in state of a substance is generally caused by the rise or the fall in temperature of the substance, like fusion or melting. First case, where the process, this is a process during which a solid on heating changes into its liquid state at a particular temperature. Okay. So this happens at a particular temperature, and that particular temperature is known as fusion point or melting point. For water, the ice which melts while heating, that is at 0 degrees centigrade, starts melting, changes its state from solid to liquid. Ice is a solid and it changes into liquid, that is water, at 0 degree temperature. The fusion point or melting point is 0 degree centigrade. Now we come to freezing or solidification. This is a process during which a liquid changes into its solid state at a particular temperature on cooling. Just the reverse process of fusion or melting. Here, the temperature at which the liquid changes into its solid is known as freezing point or solidification point of the liquid. For any substance, the freezing point of its liquid and the melting point of its solid is the same. That is, solid, that is water, becomes ice at 0 degree centigrade, and ice also melts at into water at 0 degree centigrade. This point is the same. Okay, so I stop here. I continue with the rest of the chapter in the next video. Please go through it, this and the previous video. If you have any doubt, please let me know. Write in the comment box. If you like the video, press the like button. And if you are a new viewer to my channel and if you have not subscribed yet, please do subscribe so that you can get the notification of my next video. Thank you.